Discuss about citric acid production. So citric acid earlier used to produce by chemical method. So calcium citrate used to give citric acid, because if you have calcium citrate, then you can just use any other mineral acid like H2SO4 to produce calcium sulfate, and you get citric acid solution. So it was a monopoly business for one of the Italian company to sell citric acid produced from calcium citrate. Now, later when they discovered the method of citric acid production using fermentation, then they could get citric acid produced from a different carbonaceous material, particularly beetroot molasses. So beetroot molasses is used as a carbon source, and Aspergillus niger is the fungi which you can use for production of citric acid. So essentially, for production of citric acid, the carbon, so initial we are talking about beet molasses. So beet molasses will have different polysaccharides. So different enzymes like amylase or invertase, they will hydrolyze the polysaccharides, and then it will produce glucose. And from glucose, it will first follow EMP pathway. Then it will produce pyruvic acid. And then from pyruvic acid, you will have acetyl-CoA and oxaloacetate. And these two, acetyl-CoA and oxaloacetate, will undergo condensation reaction, and after condensation, it will produce citric acid. So essentially, the hydrocarbon or polysaccharide present in the molasses will get hydrolyzed, or you can say saccharification will happen here, and then we'll get glucose. And from glucose, it will follow the EMP pathway to get pyruvic acid, and from there, it will have acetyl-CoA and oxaloacetate. And after these two compounds will actually go through the condensation reaction, and after condensation, it will produce acetic acid. Now, problem with acetic acid fermentation is the presence of iron and copper ion, and also different other mineral ion can actually participate, and they can create impurities. So most of the cases, whenever you talk about production of citric acid, you have to make sure that you use certain compound which will remove the iron from the system. So one option is to use certain compounds which are known as the chelating agent, and then chelating agent will actually try to remove iron from the system. So ferrocyanide is one of the common chemicals are used for removal of iron from the liquid. So you will have iron-free system, and this iron-free system will actually essentially help you to get uh, this conversion of glucose to citric acid. Because the citric acid can again further get degraded by aconitase and isocitric dehydrogenase, and their activity is actually quite significantly getting, their activity will get enhanced if you have substantial amount of copper ion as well as iron, because iron in most of the enzymes is actually one of the essential cofactor. So if you have iron as well as copper, as they are quite important as a component of these enzymes for degradation of citric acid to aconitase or isocitrate, then to avoid getting the degradation, you need to make sure that the system is actually having very low copper or low iron concentration. And that's why when you talk about reactor design, there you have to use glass line or Teflon line system, because citric acid is acidic, so obviously you will get very low pH. And simple stainless steel reactor will not serve the purpose, because this iron will actually get leached from the reactor and it will spoil the reaction. So while making the reactor, you have to make sure the reactor is properly glass lined, and typical blue glass cannot be used for this purpose, because blue glass has a lot of nickel, and nickel will also get leached from the glass, then they can also interfere in the reaction. So either you have to you have to use nickel free glass line reactor or Teflon coated reactor, where it will actually show inert behavior towards the chemical as well as biological substance, that is Aspergillus niger. So Aspergillus niger is one of the commonly used fungi to produce not only citric acid, many other enzymes are also being produced from this same fungi. So we mentioned about hydrolysis, beetroot molasses or beet molasses will get hydrolyzed. So Aspergillus niger will actually produce different amylase and invertase. So in the hydrolysis part also, the same organism will help to produce glucose, and in the citric acid production also it will also take, I mean, it will participate and it will produce citric acid from glucose. And mostly citric acid is used as one of the common food acid for preparation of soft drinks, dessert, jellies, and candies. Even in some cases, to enhance the taste, it is also used in wines and also in frozen fruits. So apart from citric acid, in this industry, people also use malic acid, but citric acid is more common. So here we are talking about soft drinks. So this is also used for artificial flavoring agent. So citric acid is also used as artificial flavoring agent in certain dry material. So it is, you can say, citric acid also used in as artificial flavoring agent in some dry material. And you might have seen powder. So powder will also have different kind of smell or different kind of flavor. So one of the common thing is use of citric acid to get the citrus flavor. So soft drink tablets are also available in the market, or powders are available. There also it is used for as an artificial flavoring agent. So in medical or clinical settings, citrates are also used in blood transfusion. So this particular acid can get rapidly metabolized in the human body, and also it can serve as a source of energy. In cosmetic industry also they use citric acid in different lotions to adjust pH, and also uh, for setting the hair, because obviously you have specific pH, so you can use it as hair rinse and setting the hair. So it has multiple usage. Food industry, it is also used in blood transfusion. It is also used in as a food supplement because it will quickly metabolize. It is also used for as a cosmetic material. So it is for hair rinses and hair setting. So multiple uses are there. And also when you talk about leather tanning, so bio-leather tanning can be done using citric acid. So multi-purpose uses are there. Earlier, when people used to synthesize citric acid from chemical means, then the cost was quite high. But with the help of biotechnology, when you synthesize citric acid from this beet molasses, even beet molasses also, you are not going to use prime quality beet molasses. You will just use the residual molasses from brewer industries, and then you can use, or you can produce the citric acid by first removing or reducing the iron concentration and copper concentration with the help of ferrocyanide. So the chelating agent will actually precipitate these ions, and you'll actually get the iron-free environment where the citric acid can be produced. Now, citric acid can also be produced in with the help of wheat bran. So earlier, the initial stage when people are talking about production of citric acid from different biological system, then they used to use wheat bran as so in wheat bran, they also call it as koji process. So wheat bran, whatever you get, that should be first cleaned properly, and then you adjust the pH to 4, between 4 and 5, and then you try to moist the wheat bran with steam. So add steam to increase moisture or water content. And whenever you get water content in the range of 70 to 80%, then it is actually suitable for your fermentation. So after raising the moisture content to 70 to 80%, you wait for reducing the temperature. So temperature will be reduced to 30 to 36 degrees centigrade for fermentation. Now, this solid wheat bran has already got a lot of moisture, and also you have reduced the temperature. Just one second. So wheat bran is a solid substrate. Now you raise the temperature, raise the moisture content by doing a treatment with steam. So essentially, steam is sterilizing the mat or sterilizing the solid material, and also it is increasing the moisture content. And then you adjust the pH to 4 and 5, between 4 and 5, and then you wait to reduce the temperature or wait to get that material cool down to 30 to 36 degrees centigrade temperature. And after attaining this, you inoculate the entire solid material with a special strain of Aspergillus niger. So this special strain is actually having a little bit of tolerance to iron as well as copper, and this process, this inoculum, is actually known as koji. The inoculum you add, that is also known as koji, and koji is actually a special strain of Aspergillus niger, and it will not show much. You can say it will not get inhibited by the presence of iron as well as copper. Now, when you try to do the fermentation, you try to maintain the temperature within 30 degrees centigrade. Better not to go beyond 28 degrees centigrade, because certain strain will not show good production beyond 28 degrees centigrade. So beyond 28 degrees centigrade, if you try to do the fermentation, you will not get good production. And when you try to increase the productivity of citric acid, sometimes little bit of glutamic acid is also added to improve the yield. And the starch present in the wheat bran will get saccharifed by the amylase produced by Aspergillus niger, and alpha amylase also present in this wheat bran will also get activated when you try to reduce the temperature of the bran. So at high temperature, it is not only increasing the moisture content, it is also activating the saccharifying enzymes. So you will get good amount of saccharification. And after saccharification, you go for fermentation by maintaining the temperature below 28 degrees centigrade, and you will have a surface fermentation. That means it is one kind of solid state fermentation where solid materials are there, and on top of that you just spray the fungal strain. Now this entire mixture, solid and fungi mixture, is actually spread over a tray where you try to maintain a depth of 3 to 5 centimeter. So you don't raise the height of the bed beyond 5 centimeter, because then you will have problem associated with transfer limitations. So you try to spread that solid on a tray, and the height of this bed will be 3 to 5 centimeter. and you keep it on this tray or on the floor for 5 to 8 days. So by after 5 to 8 days, you will get significant amount of production of citric acid, which you can extract by pouring water. So essentially, this solid material will actually undergo this fermentation process, the reaction we have already mentioned. And after 5 to 8 days, you will just wash the solid with water to recover citric acid. Now this is one of the way to get citric acid, and then finally you have to go for further downstream operation to purify the acid. So you will when you wash, or you can have perforated plate. When you wash, then you will get the liquid coming out from the tray, and that can be collected and further processed to up concentrate citric acid. So this koji process is actually a, you can say, solid state fermentation, where solid rice bran is kept on a tray, and this moist rice bran will be inoculated with this koji or Aspergillus niger, and as per due course of time, like 5 to 8 days is the incubation period, you will have a reasonable amount of citric acid production. But here, the production efficiency is not as high as you can get in submerged culture or in liquid surface culture. So apart from this solid state fermentation, you also have two different ways to get citric acid. One is liquid surface culture, and another is submerged culture. So liquid surface culture means you will try to grow this Aspergillus niger as a mat on the surface of the liquid. So you have a vessel where you try to grow the culture on the surface of the water. So it will actually create a mat on the surface, and humidified air is blown over the surface, because from bottom it will actually interact with the liquid and other nutrients, and to moist the surface you will just blow humidified air or humid air. You can blow on the surface. Again, here also you just do this operation for 5 to 6 days. And you have to make sure the CO2 concentration should not be very high. So whenever you have this fermentation, it will produce CO2, but CO2 concentration should be kept less than 10% to get reasonable amount of citric acid production. And the solution will have, when you start the reaction, will have 20 to 25% sugar, and you can stop the reaction when the sugar content or residual sugar content will be around 1 to 3%. And at this end of the fermentation, residual sugar concentration will get reduced, but also this liquid will have a lot of citric acid then. So due course of time, if you plot these two things, sugar and citric acid, citric acid concentration will increase and sugar concentration will decrease. Now, one option is to not to disturb the mat, surface mat. So you can have a drain point which will slowly drain the liquid, and also you have another inlet line below the mat, so you can slowly add fresh solution, and then again you start doing the operation. So it is mostly done in batch mode. The only thing is, if you have any submergence of this bed in the liquid, then that portion of the mat will not be very productive. So when you try to get the material from the outlet, you have to make sure that this material is free of different other ions. So you can use either ion exchange material, or you can use adsorption using calcium carbonate, or you can have colloidal silica, or you can have tricalcium phosphate. So this colloidal silica or tricalcium phosphate or calcium carbonate, they will actually help to remove different undesired constituents. And when you try to use different metallic ions, then before using the sucrose solution in the reactor, you can add some calcium hydroxide, and in the solution you add calcium hydroxide and raise the temperature, so it will produce different precipitates of ions, and essentially it will get removed from the system before you add the sugar solution to the reactor. So you do little bit of pre-treatment of the raw material to get rid of different trace contaminants. Like I mentioned, um, ferrocyanide you use to remove the iron. So similarly, if you need to use, if you need to remove other ions, then you can actually use, or metallic ions, then you can use calcium hydroxide, and liquid sucrose solution can be maintain it little bit elevated temperature, and all ions will actually get precipitated at the bottom of the system. Then you can use the clear liquid to the fermenter. And sometimes calcium ferrocyanide is also used to remove the material, means different ions as well as iron. So if you use calcium ferrocyanide, then you can actually get removal of different ions as well as iron. And in this process, you can actually get reasonable amount of yield, about 80 to 85% yield. So this yield is actually calculated based on initial carbohydrate you have used in the system and amount of citric acid you have obtained after fermentation. So it is one of the common method, but only problem is this stability of the mat is not very easy to maintain. So in Russia as well as some places in Argentina, they used to use this method, but it is not very popular anymore. Because if you have any submerges of the mat, that will show non-productive region, and you will get really very poor production of, or poor yield of citric acid. And another problem is the if the system is not completely iron free, or if you have small amount of iron and sodium salts, which can actually favor accumulation of oxalic acids. And also this ions can also help the mycelium to synthesize different colored pigments, like yellow color pigment or yellow green pigments. So these pigments actually create disturbance, or you can say it will actually reduce the quality of the material. So higher amount of oxalic acid is also not desired. So if you have sodium salts or iron present in the liquid or the raw material, then that can create the oxalic acid accumulation and also different kind of colored pigment, which is not desired to maintain good quality of citric acid. Now, apart from this, you also have submerged culture process, where in a fermenter, you try to submerge the same Aspergillus niger, and Aspergillus niger can have a different species. So Aspergillus niger japonicus, and it is also known as Aspergillus japonicus. Aspergillus japonicus or Aspergillus japonicus saito, they are same. It is commonly known as black Aspergillus. Is used, and instead of using stirrer, you just slowly bubble the stream, bubble the liquid with a stream of air. So the culture solution would not be very deep. You will have say 1 feet or less than a feet actually. It will not be 1 feet. It will be half a feet of height of the liquid. So in similar kind of tray, not very uh, deep liquid height. So you have a shallow liquid height in this system, say 15 centimeter, and then you just spudge air to get the mixing, as well as the air is also aeration is also helping the aspergillus to grow, and it will produce citric acid. Now it is easy to scale up, because even if you try to increase the volume or increase the height, then you have to make sure that sufficient amount of aeration is done, and here you can have little bit more control on managing different parameters. So in submerged culture, you get significant amount of improvement, and also it is not very difficult to manage. And the same aspergillus can be used multiple times. So you grow the aspergillus in the media, and in the media you can add different kind of additives to make sure that these additives will actually interact, and it will eliminate the contamination potential of iron. Even if you have very small amount of iron, this the synthetic media will actually help to eliminate the adverse effect of iron and copper ion. And you try to maintain the pH in between 1.5 to 2. So you can see in the fermentation system, in earlier case we have mentioned you have to reduce the pH to 4 to 5 for wheat bran. And in this submerged culture, we are talking about a pH of 1.5 to 2. And then when you try to inoculate, then you can just raise the pH to 4, because the fungi will actually prefer little bit elevated pH. And whenever it will start synthesizing citric acid, again pH will drop, and this different ammonia buffer, means if you use the different buffering agent like potassium hydrogen phosphate or dipotassium hydrogen phosphate, then it will try to um, adjust the pH in the system. So during growth, it will also try to utilize ammonia, and depletion of ammonia will actually result in decrease in pH. And citric acid production will start simultaneously, and you will get reasonable amount of citric acid before the pH reach to a level of 2. Means when the pH is very low, then you will not get very good amount of production. And in this reactor system, you have continuous supply of air, and mostly air flow rate is maintained in the range of 0.5 to 1 ppm. And mechanical stirring is not needed because that will create too much of shear, and that shear may not be very good for the survival of this particular fungi. So again, here also you have option to use a different kind of vessels. So as we will be handling very low pH solution, then you have to make sure that a vessel is actually not interacting with the liquid, and also vessel should not introduce any iron as well as copper ion. So glass line vessel is okay, but you should not have blue glass line vessel, because blue gas will actually uh, create problem with cobalt and nickel. So in this fermentation process, one of the important parameter is to treat the raw material using ferrocyanide, and that is true with all three operation process. Obviously, Koji process you are not dealing with liquid, whereas this other two process, surface liquid surface fermentation or submerged fermentation, there you need to use ferrocyanide to remove the excess iron present in the system, and you need to sterilize that, because after ferrocyanide treatment you will sterilize. And typically for removal of iron, the ferrocyanide concentration varies between 20 to 150 milligram per liter. So you can add ferrocyanide in stepwise manner by seeing the precipitation. So first you start with low amount like 20 ppm, and then slowly you just reduce it to 80, 100 ppm for the initial growth phase. So obviously when growth will increase, you need to make sure that the grown culture should not interact with the ions. So you have to use more amount of ferricyanide to remove the iron from the system. And when you prepare the syrup solution, before sending it to the fermenter, you can use some ion exchange system which will remove this mineral ions, especially cation exchange system, and then you send it to the fermenter. And to increase the saccharification, first you raise the temperature, and then you again decrease the temperature. And in between, if any precipitation occurs, for removal of this precipitate, you can have a fermentation filter, and then you have the fermentation in the fermenter. And in the fermenter, you can add for pH adjustment or for removal of other ions. Also, you can add lime slurry. And finally, that lime slurry will also help you to get calcium citrate. And this calcium citrate will get, you can filter it using a normal vacuum filtration unit or Dayton film filtration unit. And then you have another chamber for acid addition, because you already got calcium citrate. Now you have chamber for addition of mineral acid. So you add H2SO4. So after acidification, this calcium citrate will react with H2SO4 and produce calcium sulfate. And it will precipitate as calcium sulfate. That liquid will have citric acid, which you can actually filter. And after filtering, you can have further filtration using carbon filter to remove a different, because activated carbon is again non-specific adsorbent, so it will remove other impurities, and then you filter it again, and after filtration you send it for evaporator crystallizer, and after evaporation and crystallization you can then centrifuge to remove the excess little bit of moisture present in the system. Then you send it to the dryer, and then you go for storage. So I'll just draw the block diagram so you can have a little bit idea about the complete process. So only difference, upstream and downstream process will be similar. You can have variation in the fermenter. So the process we are describing here, it is actually to produce citric acid using liquid media. So first you have the syrup storage, or wheat molasses or cane molasses. And then it will go to a filter. Then, because here in the storage only itself, you are just putting this ferrocyanide. So ferrocyanide will create complex, or you can have calcium ferrocyanide. It will actually create complex precipitation, and this precipitate will get separated through the filtration unit. Then you send it to the ion exchange column, this cation rather. And after cation exchange, you use heat exchanger, and then after heat exchanger, you have another filter to remove the precipitate, and there you can add some additives also, because depending on the requirement of the, so additive will also get filtered. And then you will have the fermenter. So in the same fermenter, you also add the mycelium, because mycelium is obtained from a different reactor system, because you just grown the culture in sick flask and then little bit larger flask, then you transfer that to the fermenter. And after doing the fermentation, you will get, it's after completion of, because you are doing in a batch process, so in the fermenter, after at the end of the process, you will add the lime. So from the fermenter, after completion of fermentation, you will get precipitation of this due to this presence of lime, calcium citrate. So again, you will have a filter, and from the filter, the liquid will go as wastewater, and solid will go to acid chamber. So solid will go to acid chamber, where You will add H2SO4, and then again it will go to a filtration unit to remove calcium sulfate. So solid will be your calcium sulfate, and the liquid is actually your citric acid, which will go to a adsorption unit. So where you have activated carbon particles. So you just mix it with activated carbon particles, and then again you filter it, and after filtration you send it for evaporation. Evaporator crystallizer, and then if you still have residual amount of liquid there, then you can go for further centrifugation. And finally, after centrifugation, you put it in a dryer. And then you go for storage. So that is all about your production of citric acid. And then you can actually use it for different purposes. The way we have mentioned is different uses are there. So you can use it in food additives. You can use it as in medical purposes also for blood transfusion. You can use it in cosmetic industry. Only thing is, it is easily digestible for even in. So if you have any moisture present in the final storage unit, it will spoil the citric acid. So only difference is the upstream and downstream operation will be very similar. You can have only difference in the fermenter. So if you have submerged fermentation, then you will get the scheme we have used here. Or if you have the surface fermentation, liquid surface culture, there also only the fermentation operation will be different. Rest of the operation or rest of the process will be similar for both the fermentation process. And advantage with submerged fermentation is that it is much quicker, and also you get little bit better control because you use a certain amount of nutrients, and also you maintain aeration in such a way that it will help you to get desired quality as well as quantity of citric acid in the final broth. Any question?
Not currently.
Okay. Okay. Okay, then I'll stop here today, and maybe in the next class we'll discuss about one more acids, and then you can take preparation for your major exam. But make sure that you submit your assignment before by 4th April. That's the deadline for submission. And I'll share a link for yeah, assignment submission. So you can just use that link to submit your assignment.
Sure. So would the pattern be similar to the minor itself?
Oh, for major exam, we can give little bit of more descriptive question because now we'll have classroom examination. So we'll provide you answer book. With Google quiz, it was a little bit difficult because many students would say that they need to spend more time to scan the paper. So this time in major exam. We'll definitely have fill in the blanks kind of questions, but also we'll have some little bit more descriptive ones, like at least 2-3 lines you need to write.
Fine, sir.
Okay, see you on Friday then.
Thank you, sir.
Thank you.